Hey there, 6th grade. Today we're talking about multiplication and division equations. So you've already learned my three-step process for solving equations. We practiced some addition and subtraction equations. I think they seemed pretty straightforward, hopefully most of them. But now we're going to talk about multiplication and division equations. So here we go. As usual, I like to start off by giving you a picture and talk about what is it that's actually going on. Okay, we can see numbers, but help me to understand what is actually happening when we're solving a multiplication equation. So you don't have to draw this or write it down in your notes, but I hope that you can follow along. So what we have here is we have not just our variable, not just an x box, and remember it could be any variable, a g box, a q box, it could be a theta box. We could use Greek symbols or different things. But it's actually, there's an x box, but there's three of them. So it's not just one group of x, whatever that value may be, it's three groups of x. And so we think of that as being x plus x plus x, or really just 3 times x, 3 groups of x. Now what I want you to realize first is that I need to let you know that if you have a number in front of a variable, that's called a coefficient. And that tells us how many of that variable there is, and it also tells us that we're multiplying. So it's saying we have 3 x's, or 3 times whatever x is. And now if we're going to finish off this equation, what is 3x balancing with? Well, it's balancing with 12. Now I'm sure that now you see it as an equation, you can think to yourself, okay, 3 times the number is equal to 12. What's that number? Oh, I could probably tell you what that number is. But I want you to see what is actually happening on the scales. That way when we get to equations that are less obvious, the same process still makes sense. So what we're going to do here is we're going to say, all right, it's fine to know what 3 x boxes balances with, but I want to know what 1 balances with. And so I'm trying to think of how could I remove these other 2 x boxes. Well, I know that removing another one of these x boxes would be removing a third, 1/3 of the weight that's on the left side. But if I'm going to remove 1/3 of the weight that's on the left side, then I better remove 1/3 of the weight that's on the right side. So we can do that. Now we're going to remove the second third and the second third. We divided each side into 3 groups so that I could just have that one group left. We said, what if we divide it into 3 groups? Tell me how much is in each group. Tell me what is in just that one x box. But as always, if we divide the left by 3, we have to divide the right by 3 to maintain equality. So 12 divided by 3 gave us an answer of 4. Hopefully that makes sense. Let's move on. I'm going to show you some notes that I'd like you to take down. Again, I'm going to ask you to copy down our equation solving notes. So the step number 1 is to draw the scales of justice. Step number 2 is to locate the variable. Step number 3 is to isolate the variable by undoing what's been done. Well, what are we going to need to know how to do with multiplication and division equations? We're going to need to know that multiplication undoes division, and division undoes multiplication. So you're going to ask yourself, what is done to the variable? How do I undo it? And we'll see how that goes in just a second. Hopefully you already saw it. We multiplied by 3, so we undid that by dividing by 3. If you're not sure if that works, then do this little task for me. Multiply your age by 2. Carry the 1. Now divide that number by 2, and you'll get your age. You undid. Those are called inverse operations. Now I want you to try and think in your head. I am going to ask you to do this example with me, to draw the picture and to show the work. But real quick, figure out if you can understand, what am I trying to show here? What is this picture trying to show? Equals 3. That's the easy part of it. But what it's actually showing is that we don't have a full x box. What if we know that just a part of the x box, this looks like 1/3, or an x box divided into 3 parts, and we just have one of those parts. So 1/3 of an x box balances with 3. Then what is a full x box worth? That's what we're asking. We're asking, what is this variable equal to? What is the value of a full x box? In this case, what we can do is we can multiply by 3. We'll say, all right, we have 1/3, but I want 3/3, so I need to multiply this by 3. I need to have 3 groups. So I'm going to multiply this side by 3. If I multiply the left side by 3, you sure betcha I have to multiply the right side times 3. You can do it side by side or vertically, whichever you like more. And we're going to have x is equal to 9. Now if I just left it like this, my scales would be unbalanced because I didn't multiply the right side as well. That is not what I was just trying to copy and paste. So if I multiply the left side by 3, I also had to multiply the right side by 3. Oh, that didn't work how I wanted. And now it should be balanced, because if I double or triple the weight of both sides, if it stayed balanced to start, if they had the same value to start, if I triple it, they should still have the same value. A bigger value, but the same value. So hopefully you have all this work. Should be pretty straightforward. You should have those notes as well. This is example 1. We're going to move on to example 2 and 3. So here we go. And I'm going to show you when it just looks like numbers. When it just looks like numbers, what are we going to do? Well, we're going to follow the same 3 steps. I'm going to draw the scales of justice. Second, I'm going to locate my variable. My variable is p. And again, the fact that the 16 is in front, that makes it a coefficient, and it's multiplication. So I had to undo what's been done to find out what just the variable p balances with. Well, it's being multiplied. How do I undo what's been done to get it alone? I can divide by 16. If it's being multiplied by 16, I can divide by 16. So I'll do that right here. Multiplication and division by 16 are going to cancel out, and we're just going to be left with p is equal to whatever this division gives us. So you can show your work on the side just like I'm doing, please. 16 times 2 is 32. So I know it'll go into 49. 3 times 6 times 3 is 18. Carry a 1. 3 times 1 is 3 plus 1 is 4. So we get 48. Subtract. Oh, this is going to work out nicely. 16 goes into 16 once. So p is going to be equal to 31. That's the value. If I plug in 31 for p, this would be a true statement. 31 times 16 is 496. So we're all good. Example number 3. 14 and 5/10 equals j divided by 1 and 1/10. Okay, so we're still going to follow the same 3 steps. Easy as that. Draw the scales of justice. Second, locate the variable. Variable is j this time. It's on the right, but that makes no difference because the scale balances 8 pounds with 8 pounds, the same as 8 pounds with 8 pounds. It's going to bounce. Or Mr. Schwartz and a moose and Mr. Schwartz. It'll still balance. If it balances, it balances, no matter which is on which side. Now I have to say, I need to undo what's been done to isolate the variable, because my variable is j. Well, it's being divided by 1 and 1/10. So I can undo division by 1 and 1/10 by multiplying by 1 and 1/10. Remember, if you're going to use that dot as a multiplication, you better put it up high and keep your decimals down low so you know the difference. So I need to multiply both sides, and I can put it in parentheses to make it clear. Now these will cancel out, multiplying by 1 and 1/10 and then dividing by 1 and 1/10, that'll cancel out, and I'll be left with j is equal to 14 and 5/10 times 1 and 1/10. Think to yourself, is it necessary that I line up these decimals? The answer is no. 1 times these 3 digits is just going to be 145. That's nice. I'll do a placeholder 0. And then 1 times these 3 digits is going to be 1, 4, 5. I'll add 5, 1. Now, I want you to think you should know one concrete way to get the decimal point to this answer, because our answer certainly isn't going to be over 1,500. But think about the one way you do know how to calculate it, and the second way I want you to think is, what if you didn't know the rule for decimals in the answer? Would it make sense to drop this decimal down? Think about estimating. So if we know we have a number that's a little bit, 14 and a half, 5/10 is a half, 14 and a half times a little bit more than 1, where would that tell me to put my decimal? Well, 14 and a half, I have a little bit more than one group of 14 and a half. I don't have 159 yet. I have definitely more than one. Probably have 15 and 95 hundredths. So j is going to be equal to 15 and 95 hundredths. So there you go. Please make sure you have all this work. The picture included from example number 1. And as always, I'm going to leave you with some examples to do by yourself. So let's check them out. 1 says k divided by 12 equals 311. I don't like that. I'm going to change it. I'm so sorry. We'll make it 312. I think I like that more. This is embarrassing. Great, yeah, we're going to leave it at that. And number 2 is 3,678 equals 3H. So remember what 3H means. Follow that 3-step process, do your best, and I will check you later.